Let's look at what you need to know for test number 1. I promise if you can get through these problems, you will be very successful on the first test. All right, so it says using the derivative definition, which is the f of x plus h minus f of x over h, by plugging in a close value. And remember the h, you kind of get to pick, okay? So such as 0.001 or 0.01, whatever, and then be able to interpret and then know how to find the tangent line. So what will happen on the test is I will give you a function, which I give you right here, and you will have to take and use this formula and find the derivative at a particular point. And remember what that means. That means what is the slope at 5 to the x power at x equals 2. So using that definition, I have, let's start with f of x plus h minus f of x all over h. And what I'm going to do is I'm going to plug in 2 where I see x, and then I'm going to plug in some value, small value for h. Okay, and again, that's kind of your choice. Most students use 0.01 because I use that in a lot of my examples. So my x is 2, my h, let's just use 0.01, minus my x is 2, and then all over h. So now this part is where I actually use the given function. So you've seen this before, f of, and in parentheses is where you plug in where you see an x. So where I see an x, I'm going to plug in 2 plus 0.01. And then this next piece, I'm just going to plug in a 2 and over 0.01. Now, if you throw all this into your calculator, you should get something close to, I got 40.56. And again, it depends on the size of your gap, the h. Okay, but what is that? That is the slope at x equals 2. So if you drew the graph of 5 to the x, so I know that's an exponential function. If you actually drew this, what this means is if I put a point, where am I at? Right here, at x equals 2 on that line, and on that line, if it'll let me, and then I draw a tangent line at that point. Sorry, that's supposed to be actually on the line, it's just not letting me. Then that is the slope, 40.56. Now from here I could find the tangent line. Remember the tangent line equation is the point slope formula. So y minus y1 equals m times x minus x1, where m is what we just found over here. So that's the 40.56, and my x value is 2. And how do I find my y value? Well, the y value is actually this. It's where I plugged in what x is, so that'll be 25. And if you go through, I won't go through all the steps, but if you go through and you solve this for y, you should get this answer. So what this answer is, this is the equation of that tangent line on the graph. All right, so it's important that you understand what that actual equation means, what this number means. The derivative is the slope of that line. All right, so next it says find the average rate of change between 0.4 and 0.5. Okay, so for part A, basically the only thing you can do to find the average rate of change, so it says average rate of change between these 2 points, that's finding a slope. So this is like your x, this is like your y. So you would technically take the change in the y's over the change in the x's. Now, it just so happens this example is 0 because of that, but that's fine. Okay, so that is the average rate of change. The average rate of change is basically just finding the actual slope. All right, now it says to find c prime of 1. Well, the problem is one, we don't have an equation. So when you're used to seeing this, you think of writing the f of x plus h minus f of x. We don't have an equation. So the only thing we could actually do is use what we have to find the slope, which would be 0.41 and the value closest to it. And then the difference in the y's, and I get 0.9, and thus I get negative 2.2, okay, for my answer. Now, remember, this is the slope, so this is in milligrams per cc per minute. And then if I want to estimate the drug, this is the tangent line approximation. So this is saying estimate what I don't know at 1.1. I use what I know that is closest, plus the change, which is just I found above, and then the difference in those 2 points. So plugging in my values that I have, 0.41, plus what I just found, the negative 2.2 times 0.1, and I get my estimate for 1.1 would be 0.2. All right, next. So here it says fertilizers can improve agriculture production. A Cornell University study on maize corn in production, Kenya, found the average value, f of x, in Kenyan shillings. Okay, so the function is in Kenyan shillings of the yearly maize production from an average plot of land is a function of x. So x is the fertilizer used in kilograms, and then interpret the difference between these two statements. So what this is trying to get you to understand with this is the difference between the value of a function and the derivative. So the value, notice it said y equals f of x, where x is fertilizer. So this is my f of x. This would be kilograms. And then this equals the average shillings. So in other words, this is a value which basically says at 5 kilograms, the average is 11,500 shillings. All right, now here's the important part, because most of you are fine with that. That's just the value of the function. This piece, this is an actual rate. Okay, this is a derivative. You see that little prime there. So what this is saying, your x value doesn't change. So still at 5 kilograms, the average rate, and that's the key word, is changing by 350 shillings per kilogram. And that's kind of the key there, is that you're seeing the difference in the actual units. All right, be able to sketch these graphs. As I showed you in my videos, the graph of the derivatives, what I do is I look for the zeros. What are the zeros? Where the function goes flat. Okay, so that's just what I do. And where the function goes flat at 0, you are on the x-axis. So I can kind of do all of these at the same time. So where the function hits 0, you are on the x-axis. Didn't like it when I put circles in here. Okay, when it's decreasing, when it's below, or I'm sorry, when the function is decreasing, it's below the x-axis, increasing above. So below and then it increases to 0, and then it decreases. So that's actually what the derivative, if this is f of x and kind of looks like x squared, the actual derivative, if you remember in our video shortcuts, is 2x. This one here, I can see that it is increasing, so it would be above the x-axis. It hits 0, and it's still increasing. So it looks like the derivative of x cubed would be x squared. Here, the function is decreasing, meaning it's below. It hits 0. It increases, it hits 0, and then it decreases. So you see what I do is I kind of just draw if I'm below it or if I'm above it, depending on what the graph is doing. And that's it. That is your review that you should be able to do for the upcoming test.